Hello dear students, welcome back in class 9 chemistry. Students, I hope that you all are fine. I also hope that you all are watching video lectures of chemistry regularly and making your notes by understanding them. Today we will continue chapter 2, Is Matter Around Us Pure? In today's lecture, we will study in detail about various types of solution that are true solution, colloidal solution and suspension. In today's lecture, you will study in detail about true solution and its properties, suspension and its properties, colloids, its components and its properties, examples of colloids, Tinder effect and difference between true solution, colloids, or sol and suspension. Students, you have learnt about true solution and their properties in detail in previous lecture. Let us recall all those properties of true solution. Once again, true solution is homogeneous in nature. Size of solute particles in solution is less than 1 nanometer or less than 10 raised to power minus 9 meter or less than 10 raised to power minus 7 centimeter. The particles of solute are not visible even with a powerful microscope, as these particles are very small in size. It is clear and transparent solution but may be colored. You can see from the picture that if the salt or sugar is dissolved in water, it forms a clear and transparent solution, and if you add any colored salt like copper sulfate in water, it forms colored solution. But in both cases, this true solution is clear and transparent. Its particles cannot be separated by filtration method, as the entire solution can pass through filter paper. You know, solute particles are very tiny and they can easily pass through filter paper. The solute particles are too small to scatter a beam of light, so path of light is not visible in true solution. True solution is stable. That is, when the solution is left undisturbed, its solute particles do not settle down at the bottom. Examples of true solution that are sugar solution, salt solution, water in alcohol, tincture of iodine, soda water, alloys, air, etc. are the examples of true solution. Now let us do the another type of solution, that is suspension. Students, when you add soil or sand in water, do you find that like sugar in water or salt in water, sand get also dissolved in water? No. You observe that the sand or soil particles do not get dissolved in water. They remain suspended throughout the bulk of the mixture. At this time, the mixture which is formed is known as suspension. So what is suspension? Suspension is a heterogeneous mixture in which particles do not dissolve but remain suspended throughout the bulk of the mixture. Examples of suspension are sand in water, soil in water, chalk powder in water, flour in water, etc. When this type of mixture is prepared, then it means suspension is formed. Let us see the various properties of suspension. Suspension is heterogeneous in nature. You have seen that when we add soil or sand in water or chalk powder in water, the particles do not dissolve in the mixture, in the solution. They remain suspended, and you can easily find the particles with naked eye suspended in this type of solution. Why it is easy to see the solute particles with naked eye? Because the size of solute particles are big enough. So we can easily see the solute particles like sand or soil or chalk powder if added in water easily. And they form non-uniform composition of their constituents throughout the mixture. Means the solute particles like sand or soil in water does not get mixed properly. So it is heterogeneous in nature. The size of solute particles is greater than 1000 nanometer. The particles of solute are large in size, greater than 1000 nanometer. The particles are visible with naked eye. It forms opaque solution, means we cannot see across this solution. This forms an opaque solution. We cannot see across this type of solution. The particles are large enough so that they can easily be separated by ordinary filter paper. We can filter this solution and the soil particles or sand particles or chalk powder or flour remains behind in the filter paper, and filtrate is collected from the neck of the filtering funnel in the another beaker. So the particles can be separated from solute particles can be separated from solvent by ordinary filter paper. Now the another property is the particles of suspension scatter the beam of light passing through it and makes its path visible. Why? Because the particles of suspension are big enough to scatter the beam of light when passing through this solution. But when you allow the solution for some time undisturbed, what you will observe that the solute particles will start settling at the bottom due to their bigger size, due to their mass, due to gravity. They start settling down at the bottom, and the upper solution slowly becomes clearer. It means when the particles are suspended throughout the mixture, then this mixture shows the path of light when the beam of light is passed through it. But when the particles settled at the bottom, then the upper solution becomes clearer, or it seems to be homogeneous. At that time, the path of light may not be visible through this mixture. So let us see this property that particles of suspension scatter the beam of light passing through it and make its path visible as the particles are large in size and suspended throughout the mixture. But when the solute particles once settle down and the suspension breaks, at this time we will say the suspension breaks. Particles start settling at the bottom and the suspension breaks, then the upper solvent or solution or mixture may not show the Tyndall effect. Its solute particles as settle down due to gravity when left undisturbed. This makes the solution highly unstable. So these are some properties of suspension. Let us see this suspension with the help of these pictures, that this sand when added into water, it forms suspension, which is heterogeneous in nature, because we can see that these particles do not get dissolved. Sand particles do not get dissolved but remain suspended throughout the solution. Here sand is not soluble in water. This picture shows that, and slowly you can see that these are settling at the bottom when left undisturbed with the passage of time. It means solution is highly unstable. Suspension is highly unstable. And their solute particles can be easily filtered through filter paper, and residue is left behind in the filter paper, and filtrate is collected from down in the another beaker. Then this diagram, under these two diagrams, there is these two diagrams indicate that the solute particles show Tyndall effect. This mixture, when beam of light is passed through this suspension solution, the solute particles being bigger in size can scatter the beam of light and shows the path of light visible through the solution. Now let us study about another type of solution, that is colloids. What are colloids? Which solutions are called colloids? Look at this picture. In this picture you see milk is contained in a glass tumbler. It seems to be homogeneous, but actually it is not homogeneous, it is heterogeneous mixture. It is a mixture of water, fats, proteins, sugar, etc. These components are not uniformly distributed throughout this mixture. These are not evenly distributed throughout this mixture. So, this type of mixture is heterogeneous in nature and is an example of colloids. So, what are colloids? Colloids are heterogeneous mixture in which size of solute particles is intermediate between true solution and suspension, that is, it is between 1 nanometer to 1000 nanometer. Now, let us see what are the various components of colloids. Colloidal solutions have two components. Just like true solution has two components, solute and solvent, similarly, colloidal solutions also have two components. One is dispersed phase, second is dispersion medium. Dispersed phase is similar to solute-like component. Solute-like components or dispersed particles in a colloid form of dispersed phase. Dispersion medium is the component similar to solvent. It is the component in which dispersed phase is suspended, and it is known as dispersion medium. So, colloidal solutions have two components, dispersed phase and dispersion medium. Now, let us see the various properties of colloids. Colloids, it is a heterogeneous mixture but seems to be homogeneous. The size of solute particles is between 1 nanometer and 1000 nanometer. It is translucent. We can partially see across this solution, just like butter paper. We cannot see the clear picture, but we can see partially. Similarly, colloids are also translucent in nature. The particles are visible with the help of microscope. They are solute particles. Like in milk, you cannot see fats, sugar, proteins, etc. with the naked eye, but their particles are visible with the help of microscope. The particles cannot be separated by ordinary filter paper, as they can easily pass through the ordinary paper. So we cannot filter their components, we cannot separate their components by ordinary filter paper. But yes, they can be separated. But how? They can be separated through ultrafilters, like through animal membrane, which is semi-permeable membrane. They show Tinder effect, as their particles are big enough to scatter a beam of light. When a beam of light is passed through colloidal solution, the particles have the size which can scatter the beam of light when passed through it and make the path of light visible to us. We will see this Tinder effect in our next slides. The colloidal solution is quite stable. Means when you keep milk undisturbed for some time, you never see that its particles settle at the bottom. So, they do not settle on their own, but they can be settled on at the bottom when the colloidal solution is spun rapidly in the centrifugation machines. Milk, blood, paint, these are the various examples of colloids. And when these are rotated at a very high speed in a centrifugation machines, their components can be separated out. But their components cannot be separated, cannot be settled down on their own when these type of solutions are left undisturbed. Now let us see the various examples of colloidal solutions from our daily life. Foams, milk, fog, smoke, aerogel, blood, paints, these all are the examples of colloidal solution. Now let us study about various types of colloids and their examples. There are various types of colloids on the basis of dispersion medium and dispersed phase. dispersion medium is just like solvent component of the colloid, and dispersed phase is just like solute component. First type is aerosol. In this, dispersed phase is liquid and dispersion medium is gas. So it is liquid in gas type form aerosols. Examples of this is fog, clouds, mist. Fog consists of water droplets. Fog, clouds, mist all contains water droplets in air. So water droplets are the dispersed phase as in liquid state, and air in air that is gaseous in state forms the dispersion medium. Another type of colloid is aerosol, in which dispersed phase is solid and dispersion medium is gas. For example, smoke, automobile exhaust. You see that smoke is released in air, and air is gaseous in state, it forms dispersion medium, and smoke particles are solid in state, it forms dispersed phase. So examples of this type of aerosol is smoke, automobile exhaust. You can be asked what is difference between fog and smoke. Both are aerosols, but then what is difference between them? Difference lies in their dispersed phase. Both are aerosols. Both are the types of colloids. In both, the dispersion medium is similar, that is gas, but the dispersed phase in fog is liquid, that is water, and in smoke, the dispersed phase is solid, that is smoke particles. Similarly, another type of colloid, that is foam. Here, the dispersed phase is gas and dispersion medium is liquid. Example is shaving cream. That when the shaving cream is applied, in the liquid, the gas is trapped and form the bubbles, and this form a lather. Lather means foam, and this forms dispersed phase in dispersed phase gas, and dispersion medium is liquid, forms the type of colloid, that is foam, and example is shaving cream. Similarly, another type of colloid is emulsion. In this type of colloid, both dispersed phase and dispersion medium are liquid in state. For example, milk, face cream, etc. Another type of colloid is sol. In this sol, dispersed phase is solid and dispersion medium is liquid. For example, milk of magnesia. It is magnesium hydroxide in water. Water acts as liquid, which is dispersion medium, in which salt magnesium hydroxide is dissolved. It is solid in state. Similarly, mud. Mud is dissolved in water. Water is the dispersion medium, which is liquid in state, and mud particles, which are solid in state, act as dispersed phase. So it is example of sol type of colloid. Another one is again foam, but here the difference lies that dispersed phase is gas and dispersion medium is solid. Example is foam, rubber, sponge, and pumice. You have seen foam, leather, rubber, sponge in your sofas, etc. But pumice you usually see as scrubber to scrub the skin. It is this type of pumice stone where the dispersion medium is solid but the dispersed phase is gas. Then another one is gel. Here the dispersion medium is solid and dispersed phase is liquid and form jelly, cheese, butter. Jelly, you can see from here, jelly, it is solid. Dispersion medium is solid, and dispersed phase is liquid. Means in the jelly you add water. So here the more amount of solid is there, that jelly powder, and in which liquid is added as a dispersed phase, which is in the small quantity, and make this mixture gel, and example is jelly. Then another example is solid sol. Solid sol, in which both the dispersed phase and dispersion medium are solid in state. For example, colored gemstones or milky glass. These are the examples of solid sol. So you have to learn this table and their examples and types of colloids, and you can be asked various various questions from these type of colloids, that what are emulsions, what is difference between sol and solid sol, what is difference between fog and smoke, and so on. Now let us learn about Tyndall effect. Let us take three solutions: true solution, colloid, and suspension. Water is taken as true solution because several salts are dissolved in water, or you can take sugar in water, salt in water, copper sulfate in water as a true solution. Then milk in water is taken as colloid, flour dissolved in water is taken as suspension. A beam of light is passed through these three types of solution with the help of this torch. What do we observe? We observe that the path of light is not visible in this true solution, but path of light is visible in colloidal solution and suspension. What do you conclude from this? That the size of the solute particles in solution are very tiny, that they cannot scatter the beam of light. It means true solution does not show Tyndall effect. Whereas in colloid, the path of light is visible. It means the size of the solute particles is big enough to scatter the beam of light. Again, you are watching that in suspension, the beam path of light is visible through this suspension. This again shows that the solute particles which are suspended in this solution are big enough to scatter the beam of light. It means true solution does not show Tyndall effect, colloid shows Tyndall effect, and suspension also shows Tyndall effect. Now let us see what is the definition of Tyndall effect. The scattering of beam of light by the colloidal particles and make the path of light visible to us is called Tyndall effect. Let us see various examples of Tyndall effect from daily life. When a fine beam of light enters a room filled with smoke, through a small hole, the dust and the smoke particles present in the air act as colloidal particles and scatter the beam of light. This makes the path of light visible to us. Students, you normally see this Tyndall effect when you switch on headlights at night time. You see in the path of light the various small dust particles are visible. These particles act as colloidal particles and scatter the beam of light coming from the headlights of your vehicles and make the path of light visible to us. Another example, when sunlight passes through canopy of dense forest, mist or fog containing tiny droplets of water scatter the light and path of light becomes visible to us. Students, you can see Tyndall effect with the help of these pictures. You are watching that beam of light is passed through this colloidal solution and path of light is visible through it because the size of the solute particles are big enough to scatter the beam of light. Here the light is entering into the dark room and dust particles present in the dark room scatter the beam of light and make the path of light visible to us. This picture shows the canopy of dense forest. Canopy means leaf arrangement of the forest which are very dense, and when the sunlight enters the canopy of dense forest, the mist or fog present inside the forest act as colloidal particles and scatter the light coming from the sun and make the path of light visible to us. So we see Tyndall effect in the canopy of dense forest. Now let us see the difference between true solution, colloidal solution and suspension on the basis of various properties. First, on the basis of nature, true solution is homogeneous in nature, colloidal solution is heterogeneous in nature, suspension is heterogeneous in nature. On the basis of size of solute particles in true solution is lesser than 1 nanometer and between 1 nanometer and 1000 nanometer in case of colloidal solution, and the size of solute particles in suspension is greater than 1000 nanometer. On the basis of visibility, The solute particles are not visible to naked eye, even not under powerful microscope. But in colloidal solution, the solute particles which are not visible to naked eye but can be seen under microscope, whereas in suspension, the solute particles are visible to the naked eye. On the basis of appearance, true solution is transparent, colloidal solution is translucent, and suspension is opaque. On the basis of filtrability, solute particles cannot be separated by filtration. Solute particles cannot be separated by ordinary filter paper in case of colloidal solution, but can be filtered by ultrafilters or animal membrane. In suspension, solute particles can easily be separated by ordinary filter paper. On the basis of Tyndall effect, true solution does not show Tyndall effect, colloidal solution shows Tyndall effect, suspension shows Tyndall effect. On the basis of settling of particles or stability, true solution is stable, that is, particles do not settle down on their own. Colloidal solution is quite stable. Its particles cannot settle down on their own but can be made settled with the help of centrifugation machines by rotating them at high speed. In suspension is highly unstable and its solute particles settle down due to gravity when this solution is left undisturbed. Examples of true solution are sugar solution, salt solution, soda water, etc. Colloidal solution, milk, fog, jelly, cheese, shaving cream, etc. Suspension, chalk powder in water, sand in water, etc. So these are the differences between true solution, colloidal solution and suspension on the basis of some properties. Now answer these questions which are based on the topic discussed today in this lecture. These questions are also given in the exercise part of chapter 2 is matter around us pure. The question is identify the solutions among the following mixtures. Solutions are those which are homogeneous in nature. So soil is heterogeneous in nature, whereas seawater, made up of various salts in water forms homogeneous mixture. So it is a true solution. Air is also a homogeneous mixture of several gases. Coal is the heterogeneous mixture of various substances present in coal. Soda water is also the mixture of carbon dioxide in water which form homogeneous mixture. So among these 5 examples of mixture, seawater, air and soda water are the homogeneous mixtures. So these are the examples of solutions. Now see another question. Which of the following will show Tyndall effect? Students, Tyndall effect is shown by colloids and suspension which are heterogeneous in nature. But it is not shown by true solution which is homogeneous in nature. So salt solution is homogeneous and true solution. Its solute particles are not big enough to scatter the beam of light. So salt solution will not show Tyndall effect. Milk is a type of colloidal solution. It will show Tyndall effect. Copper sulfate solution, again it is homogeneous in nature and the type of true solution. Size of solute particles are not big enough to scatter the beam of light. So it will not show Tyndall effect. On the other hand, starch solution is heterogeneous in nature, is an example of colloidal solution. Here the particles, solute particles are big enough to scatter the beam of light. It means among these 4 solutions, milk and starch, which are colloidal solutions, show Tyndall effect. So this is all about today's lecture. I hope that you have understood the whole topic. If you have any query or any doubt, ask me telephonically or through WhatsApp. So students, thank you so much for watching this video. Stay safe.